All right, let's get some more practice with this because practice really is the most important thing here. So for these ones, it should be pretty quick. If you're following it, if you're not understanding how the exponential notation works with fractional exponents and negative exponents, it will be tough. But it should be pretty quick if you're doing okay with it. So yeah, try these yourself. If you get stuck and you don't know what to do, that's okay. But try to get something out with these and check your answers after the pause break in a moment. So let's pause it here. So here's my answers. The first one here is a little on the basic side where we just take the fifth root and that turns into the denominator of the exponent. Uh, with the rest of these, we got a couple other steps. With this one, first thing I would do is just that basic step of leaving it in the denominator, but write it as 1 over 5. But then if you want to move it to the top of the fraction to write it with just a negative exponent instead of writing the whole thing as a fraction, you would bring the whole thing to the top, and the denominator, sorry, and the exponent becomes negative because you brought it up like so. Then with this one, it's the same idea. I just wanted to point out that the 2x is inside the radical, so that should stay in parentheses throughout within the parentheses around the exponent. But then the 3 is not affected by this fourth root, so that should be separate on the side like that. So the 3 is not being raised to the negative 1/4 power, it's just 3. Then with exercise 2, part A here, the 1/3 here, remember, only applies to the x. The 2 is being left alone, so the 2 should not be in the radical there. With part B, the trick is that this 0.2, you can write it as a fraction. The number 0.2 is really the same thing as 1 over 5. And when you write it as 1 over 5, you can see that is the fifth root of x. Similar idea with this one. The 0.25, we're going to need to write that as 1/4. But also, because it was a negative exponent, we're going to bring it to the denominator of the fraction, and then write that as that 0.25 is a 1/4, and then you end up with this. And you could do this in a slightly different order, or maybe you're skipping some of these steps. As long as you're getting the right answers here at the ends, it's probably fine. Okay, now I'd like to go over a couple problems from the problem set in the problem set homework. Number 10 was assigned for you. That's part of your problem set homework. But I'm going to do 11 and 12 here. So what these problems are asking you to do is to write this whole expression as a sum of terms in the form k times x to the p. So each of the terms should be like that. By the way, terms are things that are generally being added and subtracted. So if you have something plus something else plus something else, those are 3 different terms. Or if they're being subtracted too, it's the same thing. So as long as there's no addition or subtraction happening within the term, you usually call that a term. So anyways, each of the things being added or subtracted here, we want to write as a number times the variable x to the power, which is also a number. So right now, it's not like that. So for 11, what I would do here is, first of all, use the fact about fractions that in general, if you have like a plus b over c, and you want to split that up into 2 different fractions, you can, because it's the same thing as a over c plus b over c. And that's just because that's how you add fractions together. If the denominators are the same, then you can combine them into one big fraction there. So that's what we're going to do with this one. I'm going to write it as 6 over the denominator here, which is 2 times the cube root of x, minus the cube root of x divided by 2 times the cube root of x. So the denominator is not changed, I just split it up into 2. In the one on the right here, this is pretty simple because that factor just reduces, so I can just rewrite that part as 1 over 2. But then the one on the left here is a little bit messier. So if we're trying to write it with the x in the top of the fraction, first I'm going to write that radical, that cube root, as an exponent, but it will be to the power 1/3. So it'll be 6 over 2 times x to the 1/3 power. That's the same thing as the cube root of x. And then you can move that to the top of the fraction and write it as 6 over 2, but then times x to the negative 1/3 minus 1/2. And of course 6 over 2 is just 3. Could have done that in the first step, I guess, but that's going to be 3 times x to the negative 1/3 minus 1/2. This is basically what it's looking for. Each of these you can think of as a power function. This here, the first one, the k is 3 and the p is negative 1/3. With this other one, it's not quite written like that, but negative 1/2, you could remember, another thing to remember here on the side is that x to the power 0 is always 1. So I could just write this with an extra x to the power 0 there, and it doesn't change it. So that way I'm really following the directions. Okay, so then let's do 12 here. With this one, I'm going to start by just using the distributive rule and just write out the same thing, but with each of these three terms individually multiplied by x to the negative 0.5. So we got x to the negative 0.5 times x, that's the first one, plus x to the negative 0.5 times x to the 0.25, that's the second one, minus x to the negative 0.5 times x to the positive 0.5. So I just took this thing and multiplied it by each of the three terms in there. Okay, now we have that. We can use the rule that says how to combine exponents when they're when you have a power times a power. I'll just use the sidebar here as a reminder of some rules. If you have x to the a times x to the power b, you get x to the power a plus b, in case you're forgetting that one. So here I'm going to do this exponent. We got the negative 0.5 there, but then what's the other exponent here? If it's not written there, if it's just x, that means the same thing as just x to the power 1. So this is going to get combined into x to the negative 0.5 plus 1. And this other one here is, these two get combined into x to the power negative 0.5 plus 0.25. These ones become x to the negative 0.5 plus positive 0.5. Let's just do the addition now. Negative 0.5 plus 1 is positive 0.5. Negative 0.5 plus 0.25 is negative 0.25. And here, negative 0.5 plus 0.5 is 0. So I'm going to write this as just x to the 0.5. And if you want to write it, just so you can be clear what the k and the p are, if you want to write it in that form, the k is the number 1, and the p is 0.5. Here you have this plus 1 times x to the negative 0.25. And anything to the power 0 is always 1. So you could either just write it as the number 1, or if you're really trying to follow the rules and write it as a number times x to a power, instead of writing 1 there, you would write that as 1 times x to the 0. Anyways, that's what 11 and 12 are like. I'll leave 10 to you when you get to the homework.